All right, ladies and gentlemen, welcome. My name is Brian McLogan, and I am going live. I am sorry, I am having some technical difficulties. My children were not going to bed, so I had to be delayed. And then I do not want this to be a members only mode. God. Oh my God, why is everything getting into there? So I apologize, guys. I am not having my luck here with the live stream. Jeez. Okay. I see you guys in there. Yes. I am going to turn off the member stream because I do want to take in your guys' questions. So just give me a second with that while I go ahead and get that all edited for you guys. I did want to let you guys know I did spend some time actually in my members area, making sure I added up my, let's see here. No, what is, can I not edit? All right, there we go. There we go. Now that is removed. Hopefully that is done now for you guys. That's pop-out chat. Awesome. So again, guys, sorry about I'm trying to get used to this new YouTube studio as far as them getting us prepared for, when they're going to switch over to this live streaming. And I am not sure why every single time I try to use their new studio, it just does not want to connect with my account. So I'm not sure if it's the software I'm using. I'm not sure if it's the YouTube app. It's just whatever. Every single time I cannot connect the stream. So I keep on having to revert back to the old live stream, a little software that they had for us. And that's just the way it is. So either way, guys, I am going live, and I do have 4 questions that I'm going to answer today. And then hopefully I will have some time to get to you guys. I am about 17 minutes late, and as I do apologize. Part of that was from my kids not going to bed on time. And then the other part of it was my technical difficulties that I probably tried to go live maybe 4 or 5 times. So I do apologize if you were in that other area. But hopefully you guys see that I am live. And then obviously I see some of you guys are jumping into the stream. Like so many of you, Solomon, Armel, Genesis, TTV, Clarissa, Joey, Michael. Good to see you guys there. XD, thank you so much for joining me, guys, on the stream. I am going to cover a couple of these. I did want to let you guys know there are a couple things that I know we're kind of going through the holiday weekend. We only have classes this week for Monday and Tuesday. There are a couple things I did want to let you guys know about that, might be beneficial. I am looking into releasing a review for those of you that are kind of in pre-calculus, algebra 2, college algebra. Basically just kind of making them available, my reviews that I'm giving to my students already have, as well as their semester review, which I gave out to them last week. So if that's something that would be benefit for you, make sure you guys just take a look at or pay attention to. I'll probably be either having a video probably early next week with some more information for those of you that, would benefit from some extra kind of practice problems and just kind of review of what you should prepare to help you prepare for your semester exam. I've also kind of worked into my members area, made sure that I got some of those documents as well as some of the videos that I was going through my class for those of you that are more interested in a lot more of the content that I provide. Obviously, this is all free as far as my videos, these live streams that I'm doing for you guys. But obviously, there is an opportunity for those of you that are taking pre-calculus or really take advantage of a lot of the extra elements that I do. Those in the member areas, I have all of my content, all of my answer sheets, all of my blank documents. Everything is up in there that you guys can take a look at and see if that's something that's, right for you. I have that available as another option. But otherwise, I'm happy to continue doing these live streams every week for you guys, answer your questions. Again, you can always submit your question on the community tab. In addition to going out on Facebook, I also make sure I have the post there as well. So that is where these questions are come from. And I know some of you, forget about it or something was going on today. So maybe you're just getting into the YouTube or just getting onto the app, but I will maybe try to see if I can answer some questions for you guys. Oh, and that was the other thing I was going to do. I also have some, I guess there was like some no super stickers or something else that YouTube was coming out with, but I also have some different emojis and everything else. So for those of you guys that do support my channel with the membership, I do greatly appreciate it. There are definitely some more things coming around. It's always crazy beginning of the year getting everything started teaching, but there are some things I wanted to do that I didn't get done early, that I am getting myself now caught up on as we're trying to like end off this year. So those are some things that I look into introducing to you guys at the beginning of the year. So, all right, awesome. So I see a whole bunch of you guys have joined on in. So welcome to the live stream. Let's go ahead and get onto the math, and then I will take more of your guys' questions, as I know you guys, a lot of you are just kind of adding into the stream, which is awesome. So somebody submitted this question. They didn't use parentheses, which you can see is kind of important because I don't know if they meant 2 to the x minus 1 or 2 to the x minus 1 or 2 to the x minus 1 equals 10. Now, reality, I mean, I don't have a calculator, and so I'm only going to solve this as far as what I can do without a calculator to help them out. So on this left side, the main idea here is we have this, exponent 2 to the x minus 1. We're going to want to isolate that. So we're going to add the 1 to both sides, and then I have 2 to x equal to the 11th power. Now, again, when we need to go ahead and get the x off the denominator, or x off the power, right, we want to solve for x, what we're going to do is we're going to take the log of base 2. And we're going to take the log of base 2 on both sides. Now, what that's going to do is our rules of logarithms, that is just going to bring down that x, and log base 2 of 2 is just 1, so x times 1 is x. So therefore, in our calculator, we would just need to go ahead and type in log base 2 of 11. And if we needed to use like the change of base formula, because our calculator is not doing that, we could use the natural logarithm of ln 11 over ln of 2. If you're like, why are you doing ln? You could do log base 10. Doesn't really matter for the change of base formula. I always prefer using ln. Just, I don't know. I always like it. On the next example, we can see that this is already isolated. It's just 2 to the x minus 1, like x minus 1 is in the power. So now I'm just going to take log base 2 of both sides. That's going to leave me with an x minus 1 equals log base 2 of 10, and then I'll just add a 1 to both sides. So x equals log base 2 of 10 minus 1. So you can see completely different answers, right? Obviously, the process is relatively the same, but again, just that's why parentheses, guys, are so important. Not only right now I'm grading the last quiz that we gave. I did a video last week for you guys on the first quiz on trigonometry. I'm grading those, and students are getting a lot of problems wrong just because they're not, they didn't use their parentheses, and or they mixed up a problem because of a negative. And, like little mistakes, the way that I grade is, I'm not here to, say you don't know anything because you made a little mistake. But in the same respect, little mistakes, they can have a huge impact. Like, I don't know where where this -1 was supposed to be. And you can see these answers are completely different, right? So the process is relatively the same, but the answer here is completely different. All right, the next one, trigonometric equation. I am not sure, they did not give me an interval how I was supposed to solve this. I think I have 2 equations though, right? Yeah, so let's do this one between 0 and 2 pi. So it's common when we're doing solving trigonometric equations that we'll either have an interval or it'll say find all solutions. Now in this one we have a sine and a cosine, and typically, guys, just like with quadratics, when you have sine and cosine on the same side, basically what we're going to want to do is get them to the same side, set it equal to 0. We don't want to divide by sine of theta on both sides. We don't want to divide out our functions, right? We're trying to solve for our angle theta. So we don't want to be dividing on both sides. That's not going to be a proper technique. So I am just going to solve or subtract a 2 sine of theta equal to 0, sorry. Now you can see that both these equations, they share a sine of theta. So, you can kind of think about this like a 4x and a y, like a y squared. Like you can factor out the sine of theta. They share them in common. So I'm going to, oops, not a 4. And actually they share a 2 in common as well. So let's factor out a 2. Sine of theta. And by factoring out 2 sine of theta, that's going to leave me with a 2 cosine squared of theta minus 1 equals 0. Now I can go and apply the zero product property, right? I have a product times another, or sorry, a product of two expressions equal to 0. So now I can set them both equal to 0. And therefore, to cosine squared of theta minus 1 equals 0. So again, this is just a scalar, so that's not going to change anything. And then here, that's going to give me, now this one's interesting, cosine squared of theta equals 1/2. But remember, we need to undo the squaring, right? So we're going to square root. And again, since we're introducing the square root, we need to use plus or minus. So that is going to be plus or minus. Now, again, that's going to be 1 over the square root of 2, which ends up being square root of 2 over 2. So again, that's a plus or minus square root of 2 over 2. So to find the solutions, we need to go back to going to the unit circle, right? So basically we're saying, the sine of what angle is equal to 0? Well, between 0 and 2 pi, there's two angles. Like here's the unit circle. When is sine equal to 0? Well, 0 and pi, right? And again, that includes 0, but does not include 2 pi. So you can see the y coordinate, point on the unit circle, is going to be true for at 0, or equal to sine of that angle is going to equal to 0 at 0 and, so I'm going to use set notation. So 0 and pi. Then I say, for what all the values is cosine of theta equal to plus or minus the square root of 2 over 2? Well, cosine, or all square root of 2 over 2 for the x-coordinate, is going to be all of these angles, which is basically, pi over 4, 2 pi, 3 pi over 4, right, at that point, 5 pi over 4, and 7 pi over 4. So, well, those are your angles. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I don't know why I use a parenthesis there. And that's just another horrible bracket, but we'll just roll with it. All right, for the next one, I just completely made up this problem. I really do not like just making up random problems because I'm not even sure if this is going to work. But they said it wanted something with, I think, direction and magnitude and then adding vectors. So I said, all right, it's been a while since I've done this, so let's try to remember. Let's try to remember a couple things that we have for our magnitude. So, magnitude of our vector, like v here in this case, be 2. Now again, if we're going to write the equation of a vector, we could have the magnitude times the cosine of theta, sine of theta. So that is what we call our unit vector. Because again, what are those points? Cosine theta, sine theta. Those are points that are on the unit circle. So this is kind of connected, right? And obviously once I get to this, as far as instruction goes, we make those connections with the students because obviously this will be in our applications of trigonometry unit, which is going to be happening here in a couple months for my students. So what I did here is I basically say, all right, well, if we're going to have a magnitude of 2, and then the cosine of 30, that's going to be, so again, you can just distribute that 2, right? So my vector here is going to be 2 cosine of 30 degrees times 2 sine of 30 degrees. And then we're going to add these because that's what the student asked, I believe. For here, going to be a magnitude of 3 cosine of 60 degrees, comma 3 sine, oops, I'm sorry, that's a negative 60 degrees, isn't it? Negative 60 degrees. Well, let's put those in parentheses. It's kind of weird. So obviously the problem can be presented a little bit differently, but basically it's like relatively, if you have the magnitude and the direction, right, you can basically write any vector into this format. And that is basically our form for when you have magnitude direction. Again, magnitude is, basically the length of the vector. And then the direction is going to be from in standard form. So if you have magnitude direction, you're just going to write the vector in this format, which is basically taking this unit vector, right, if you had like a unit vector, and then you're just expanding it or, stretching or compressing that unit vector. Now we just need to add the vectors. So really what we need to do here is when you're adding vectors, you're just adding components. And I'm not going to get to the graphical portion of this, but basically you're just adding the x component and then you're going to combine the y components. So now, kind of like what we need to do here, we just need to figure out what is the, sine, cosine, tangent of all of these values. So 3 sine. And this is why I ask students that if you have a question about something specifically, it's always helpful if you can give me a question or something related about it that I can talk about, because then otherwise I have no idea if I'm actually helping the student out or not. I only had 4 questions, so I said, well, I might as well just, actually I had 5 because students came in to the end. But, I was like, well, let's kind of go through it. I'll pick a problem and hopefully this is something that helps you out. Let's see, the cosine of 30 degrees here is going to be square root of 3 over 2. So it's going to be times the square root of 3 over 2. Plus 3 cosine of negative 60. That's going to be 3 times negative, no, cosine, that's positive. So again, this is going to be in the 4th quadrant. So it's going to be 1/2. Comma, sine of 30, that's going to be 2 times 1/2. Plus sine of negative 60 is going to be 3 times sine is going to be negative square root of 3 over 2. So these are not going to be like terms, so there's nothing that's going to simplify. But we could just kind of write a, for the answer, 3 plus 3/2, comma, 1, and that's going to be minus 3 square root of 3 over 2. So there's your, there's your vectors. Obviously, you could put them under together as fractions if you need to. But again, like I said, I just made up some problems, so hopefully that one works out. All right, the next student asked for, one to do with double angles. And again, that's not something that I've covered since last year. So I just don't have any problems or anything created. I don't even remember all the formulas for double angles of cosine, so I just kind of did a quick look and I was like, all right, let me just kind of do a problem, which is very similar to what we did here. So, when we get into solving trigonometric equations, a lot of times if we just have one isolated double angle, there's ways to save it without using the double angle formula, which is a lot easier. However, in this case, you can see we have sine of 2 theta plus sine of theta. Well, we can't combine them. They're not the same trigonometric functions. This one's of 2 theta, this one's of theta. Oh, well, thank you very much. You caught my eye, Polynomials Adra. Find the area of a cylinder. I do appreciate it. I will do my best to make sure I can add that in there. As far as cylinder, I like that. It's been a while. So if you do have one though, actually a cylinder you want me to cover, I will do that. Otherwise, I'll just explain the concept and then give you the form at the end. So thank you so much for the super chat. I really do appreciate it. I don't think I missed anything else though, did I? Hopefully not. All right. Definitely see a lot of you guys coming into the chat, which is awesome. Thank you guys so much. I would, again, highly recommend though. I do apologize, guys. I'm just not going to be able to get to all the questions that come in on a chat. So, if you do have that opportunity to ask those questions ahead of time, I always try to make sure that I post the questions or for the community chat and everything for you guys to post your questions below ahead of time. So just try to make sure if you have the time to go ahead and do that. So therefore I can make sure that you are on the list. All right, so in this problem, we need to use the double angle formula. Otherwise, there's a little bit easier way to do it when it's just one isolated. But let's not worry about that. For right now, let's use a double angle. Sine of 2 theta is going to be 2 sine theta cosine theta plus sine of theta. Now, again, we're going to be finding all the solutions. And again, I made this problem up, but I believe this one works. So here, again, you can factor out the sine of theta. That's going to leave you with a 2 cosine of theta plus 1 equals 0. Yeah, this one works. All right, perfect. So now we can use the zero product property just like we did before. So sine of theta equals 0. And then 2 cosine of theta plus 1 equals 0. So therefore, cosine of theta, subtract the 1, divide by 2 equals negative 1/2. Okay, so now we need to identify again by the unit circle where all of these points exist. Now, this one's a little bit different than the last one, just because of the fact that we're just not looking for all the solutions between 0 and 2 pi. We're looking for all the solutions. That means infinite repetitions going around the unit circle. So the first one, when is sine of theta equal to 0? Well, we already talked about that one last one. That's at 0 and pi. But again, 0, then pi, then we could add pi. We could add pi, and we could add pi infinite many times. We could also go in the opposite direction, right? So we could have negative pi, negative 2 pi, and so on and so forth. So the way that we look at this, and actually, what do I explain? how would I teach that? Oh, I guess I would say find all of the solutions between 0 and 2 pi first. That's what I used to teach. Okay, so I'd say let's do the solutions between 0 and 2 pi first. So between 0 and 2 pi, that's going to be 0 and pi. Now, that's for the other one. Sorry, I'm confusing my instruction. We haven't got to this yet, so I was trying to think of, but what is the best way? But no, that's what we do for the double angles when they're isolated. We don't need to do that for this. So basically, what we need to do here is list the first solution, x equals 0, and then plus pi. Now, again, I could add pi infinite many times, right? So we're going to use a variable. Now, this is something we just taught in my class. So we're going to use the variable n. Because if n is 0, then we have a solution at 0. If n is 1, we have a solution at pi. If n is 2, we'd have a solution at 2 pi. And you can see for every interval of n, this works. Now, we really don't need to have 0 here. So we can write a final solution here of pi n. All right, the next one is, what about when cosine is equal to -1/2? Well, cosine is equal to -1/2 if you go through the unit circle for that angle and that angle. So we have these two angles. Now, these two angles are going to be x equals, let's see, that's going to be 2 pi over 3, and x equals 3 pi over 3, 4 pi over 3. I hate when that does that. Okay, so what we have here is, again, there's really no relationship. Like, you can't add pi. If you add pi to 2 pi over 3, that's going to take you over here, which would be 5 pi over 3, right? So that doesn't work. So the only time to get infinite many answers here is going to be adding 2 pi, right? And you could add 2 pi once, twice, 3 times, or either way, we're just going to add 2 pi n number of times, just kind of like in this case. So this one's going to be x equals 2 pi over 3 plus 2 pi n, and this one's going to be the exact same answer, 4 pi over 3 plus 2 pi n. So that's basically how you handle those in the difference between finding the solutions between 0 and 2 pi, and then finding the solutions between, or finding all the solutions. And again, if you have some repetitions, that's what you want to look at as far as, instead of adding 2 pi to 0 and adding 2 pi to pi, we could just say add pi to 0, and that's going to give you all those solutions as well. So that's just one of the ways to kind of cut down on the redundancy of your answers. All right, looks like we're doing all right with time. I'll try to get you guys in the questions. The last one I had here was basically just a kind of Pythagorean theorem problem. So I did kind of like a basic one, and then I did one that's a little bit, not as nice. So just remember the Pythagorean theorem. Obviously we have the hypotenuse, which is always directly across from 9 degrees, and then we have our two legs. So a lot of times, most students have it memorized as a squared plus b squared equals c squared, where a and b are the legs of the triangle, the angles that are the side lengths that make up the 90 degree, and c is the hypotenuse. So in this case, you can see that we have our two legs, and we just need to figure out our hypotenuse. So we're just going to do 3 squared plus 4 squared equals, c squared. And again, guys, I'm just going off of, they asked me to do Pythagorean theorem, so I'm just making up some problems. However, if you can go over, some problems for me, or at least kind of know where you're getting trouble at, I can help you out a little bit better, or hopefully a little bit better. So now we have 25 equals c squared, and then we're going to introduce the square root. In this case, for these types of problems, negative numbers or negative sides of triangle don't make any sense. So therefore, c is just going to be positive 5. In the next example, we don't have this side, so we're just going to call this x. Now again, you could call it a or b. Doesn't really matter, right? And again, you don't need to use a, b, and c. Like, it's leg squared plus leg squared equals hypotenuse squared. So let's do this. X squared plus 1 squared equals square root of 2 squared. Oh, actually, I didn't really pick one that too bad. So in this case, x squared plus 1 equals the square root of 2 squared, which is just 2. Then subtract 1. X squared equals 1. Square root x equals positive 1. So this actually ends up being a 45, 45, 90 triangle. So either way, there's a lot of different types of complexity with the Pythagorean theorem with radicals and simplifying radicals. I'm not sure if that's what the student wanted or they just wanted some basic stuff. So again, guys, that's why I always ask for some additional, always kind of context when you're doing these. The 3, 4, 5 triangle is also known as a Pythagorean triple. There are many other Pythagorean triples, and those are nice because we don't have to deal with any radicals as a side length. So that's always something helpful. All right, so I did get one more super chat before I get to you guys or get to everybody else that has kind of commented. I will try to get to maybe some extra questions, see if I can help you guys out. But finding the area of a cylinder. Okay, so to find the area of a cylinder, we need to understand what the shape of a cylinder looks like. So a cylinder is going to have a circle base. Okay, this is bad, but there you go. Okay, so that is a cylinder, right? So basically we have a circle base, right? And then and basically, I don't want to kind of get to these layers, but you can see that that same base is just being basically repeated and like layered on top of each other, right? So you could do like layers of this adding on top. So the way to kind of find and I'm assuming they wanted the surface area. So to understand the surface area, we basically need to create what we call the net. So the net of this is basically going to be like if this was wrapping paper or something, yeah, basically like wrapping paper. So I don't know what present this would currently be, but if this was going to be something you needed to like wrap, what basically would you be covering this with? Well, we're going to have a top, which is a circle, and we're going to have a bottom, right? So we can just call this top, we'll call this base, and we'll call this sides. Okay, so to find the surface area, we obviously have the height, right? So we'll call this the h, right? We obviously, for both the top and the bottom, you can see those are the same. So really only need to figure out this once. And so therefore we're going to have a radius, right? Now we need to figure out the area. Well, again, remember the area of a circle, area of a circle equals pi r squared. And then the other thing we need to figure out is, well, how far is it from here to here? Well, how far is it all the way around the circle? Well, again, remember that's the diameter, right? So the diameter of a circle equals 2 pi r. So again, everything is relative to r, but again, from here to there is 2 pi r. Okay, so and then this area is going to be pi r squared. That area is going to be pi r squared. So the formula for surface area, or at least explained, is going to be pi r squared, which is like, let's see this. It's basically going to be the top plus the base plus the side. And I don't know why I call that sides because there's only one of them. All right, so let's kind of break this up. The top is going to be pi r squared. The base is going to be pi r squared. And the side is going to be, that's a rectangle, right? So it's going to be 2 pi r times h. Well, these are combined, so we can say 2 pi r squared plus 2 pi r times h. And that is the surface area. Now, obviously, you could simplify this a little bit further. You could take out a 2 pi r, I guess, if you'd want to do that. So that'd be r plus h, maybe. I don't know if that's any simplified answer or not. But there you go. That's at least the formula and at least understood as far as how we got those side lengths. So hopefully that helps you out. Again, thank you so much for the super chat. All right, guys, let's kind of get back in. So I am kind of done with that. I'll see if I can answer some of you guys. I'm at the 30-minute mark, but let's go ahead and see what we got. So we got Carter, Lulu, Reforso, Valerie, Alex, Connor. Thank you so much. I am in pre-calc because we're getting it down. Awesome. All right, completing the square. No, I don't want to do completing the square. Carter, what do you have questions on completing the square? I'm just joking. I've really actually, it's kind of interesting you asked me about this. I'm going to go back to some other questions, but I want to cover completing the square because or at least just one of those, because it's one thing that is I've kind of changed up my instruction for completing the square. And I'm not sure, because every single time I'd always teach completing square, students are still like, I just don't get it. Like, it's, it doesn't make sense, and, whatever. And I was, I obviously a lot of it is just practice with that, and that will overcome them. But there's something that, I'm not sure as far as if my instruction was maybe needs to be altered. So I kind of have a different change here. So I'll cover those as far as completing the square. Hopefully that helps. Kind of sum and difference identity. I don't remember the sum and difference identities. I do. It's just cosine of x. There's just not enough time for me to do one of those problems. Yeah, that looks like a pretty good problem too as well. Sorry, God, I'm just not gonna have time to do that. It's cosine of x cosine of x, cosine of y, minus sine of x times sine of y. So yeah, but that's a very detailed problem that's going to take me a while to even solve and look through. And obviously I'm at the end of the stream, so I'm just not going to be able to get to it. I apologize. But if that is still a question that you have for next week, feel free to shoot it over to me, and I'll be more than happy to kind of add that in there. Hola. All right, factoring polynomials. Yes, I know, factoring. Need help with solving with logs, not the same base. Kind of, as far as with that, well, it's been a while. I don't teach logarithms as much anymore, so I haven't really got into it, and I haven't taught the calculus, so I'm not really sure off the top of my head what you're going to want to do for in that case. It feels like obviously it's something that I should remember. It's just not coming up to me, so I apologize. That's not something I'm going to be able to cover for at least at the end of this live stream. Edward, I'm not sure what introduction to functions that you need. I do have a whole bunch of videos though on functions. So hopefully some of those older videos will help you out. Polynomials, factor polynomials. I can definitely factor a lot of polynomials. If you guys have maybe a polynomial you want me to write though, that'd be great. I'd really appreciate that. Write in A plus BI form. I don't have a calculator, and I don't know how many times, Vesper. I'll tell you what you need to do. You basically, I'll tell you what you need to do. I'm not going to do it though for you. All right, that's negative I raised to the 575 in A plus BI form. Never mind. I'm not going to be able to. Kind of like, you guys are getting me on these formulas, or just come through this. Oh, that's negative I. I'd have to look at that. Sorry, guys. I'm just kind of at the end of the stream, so I'm just trying to maybe add on a couple other questions that are not going to take me too much longer to go and add on. Again, EL, that's just not a problem. I'm just going to be able to cover here rather quickly for this, because now you're going to have an X. Yeah, it's a little bit more complicated than I'm going to be able to finish off this, so I apologize for that. But I see you guys. Oh my God, it's like I say, all right, open questions, and you guys just badger me with a whole bunch of stuff. This is awesome. Yeah, for as far as the same base, I would have to go back and just remind myself as far as what to do. I just do not recall back in this. Black Pen Rip Pen, great to see you, man. Good cheers, man. Happy to have you on the live stream. We've been going for a while now, so it's always a pleasure to have some more some math knowledge around on the game. And factor a very hard polynomial. Slope out of this. You guys are adding in this. Yes, I love Black Pen Rip Pen too. It's awesome. Very, very good, guys, to definitely get. And there's a lot of questions. And again, as I mentioned, guys, a lot of these, from this live stream, going so far here with these questions that I got, at least up to this point for you guys. I just always bring in the importance, guys. I'm going to plan on being live again next week on the Sunday. And if whatever questions you guys can, provide to me ahead of time, that just allows me at least to get a little bit prepared, and obviously just make sure that I have enough questions to kind of go through the live stream, because obviously once I add on to things, that get through this. I always try to keep these live streams roughly around 30 minutes. We never, finish off on 30 minutes, but that's usually the way things go. But, obviously a lot of you guys are bringing in a whole bunch of questions here at the end, and I feel bad because there's no way I can get to any of them. But obviously, if any of you guys have any of those additional questions, and I'm sure you probably just gave Blackburn Ripon a whole bunch of some great ideas as far as some questions to be able to answer, because obviously his channel, if you have not checked out his channel, I would highly recommend go and take a look, because he answers a lot of math questions that I think a lot of you guys would enjoy and benefit. So I definitely would recommend checking out his channel in addition to getting the answers, for your work that you guys need. So I'm going to go ahead and finish off this live stream with just kind of doing this understanding of the completing the square, just a little bit different than, one of the things I've been looking at, because a lot of times I would get into completing the square with this b divided by 2, this whole idea of this converting to the vertex form for the students, because that's basically, we used it, and, it was one of those techniques that it was used, but it wasn't as common. Typically when we're solving usually quadratic formula would be a little bit easier. And students always just kind of forgot about the, b divided by 2 squared. And obviously for some problems that's very helpful to remember, especially, when you get into some more complicated ones. But in the same respect, it's not something that I think for a lot of the completing the square problems that you can, that really you necessarily need to always remember. So case in point here, let's just kind of go through these two trinomials, right? These two trinomials are what we call perfect square trinomials. And if I'm just going to go ahead and factor this is going to be x plus 1 times x plus 1, which can be written as x plus 1 squared, right? And for this one, it's going to be x minus 1 times x minus 1, which is s minus 1 squared, okay? So these perfect square trinomials, as factored, you can see the factors are the same, are going to produce this binomial squared. Very important. That's very helpful if you're solving a quadratic, or if you're trying to find something in the vertex form, for instance. So one of the things is, if you can see, this is not factorable, right? So we can't factor this. This is not a perfect square trinomial like these two. And then if we're just going to be factoring these in case, we have x squared plus 2x plus 2. There's no two numbers that multiply to give you 2, add to give you 2, right? So one thing though, if our goal is actually to rewrite this as a perfect square trinomial, I recognize this x plus 2x is the same as over there. So what I'm going to do here is I'm actually just going to create that perfect square trinomial. I'm basically just going to add the 1. Now, obviously I don't have an equation here, so you can kind of go by that game. But basically the idea is, like, if my whole goal is to create this binomial squared, then if I already have x plus 2x, I'm just going to go ahead and create that. Now again, in the form of the b divided by 2 squared, that's going to be 2 divided by 2 squared, which equals 1. And that's basically where this 1 comes from. But again, a lot of students have just always forgot it. They always confuse it. They make mistakes. So I've kind of changed my ways a little bit. And so what I basically, said is, like, forget about this constant here. If I have this x squared plus 2x, right? Basically understand, I want to create this as a perfect square trinomial. So therefore, I recognize that x squared plus 2x plus 1 is the perfect square trinomial. I'm just going to add 1. But again, like an expression, guys, if we're just going to add 1, that's going to obviously change the value of the expression, especially if we had something as an equation. That's going to change the equation. So therefore, we just need to make sure we subtract the 1 on the outside to keep everything, kind of honest here. And then we still have that plus 2. Well, now we can factor that to a binomial squared, x plus 1 squared, which we already knew. And then we can just simplify that to a negative 1 plus 1. All right. All right, guys, I do apologize. I know I have at least a little bit 15 minutes over my original workload here, but let's just get into a Discord server. You know what? I actually looked into that as far as the Discord server, and yeah, I don't know. Maybe you guys can help me out with that. It was one of those things I did look into it because I am on that as far as another membership, a couple other membership sites that I'm around. They have the Discord server, and I don't know. I guess maybe I'll have to look at it a couple more time with you guys. But I'm going to have to end off the stream for you guys now. I do appreciate you guys getting into the questions. Thank you so much, guys, for joining in the stream. And I do apologize for the issues I had at the beginning, but I do appreciate a lot of you guys adding into the chat, especially on your Sunday night before, especially at least for those of you in the United States, coming up into Thanksgiving. And again, I just want to remind you as well, I will be providing you guys a free review for semester 1 review. Basically, I have my reviews that I kind of gave my students in pre-calculus. Again, our pre-calculus course is a little bit different. I know it might not transcend for everybody that is taking the pre-calculus, but at least that's the only course I'm teaching this year. So I'll have at least the reviews as well as my semester review that I just gave out to my students. So hopefully, if you are taking a pre-calculus, trig, college algebra, algebra 2, I think there's definitely going to be some problems and some topics that are going to be a good review for you. It's not designed to be a complete full review for your class. Obviously, that's something you're going to want to get with your teacher and instructor, but hopefully, I will have the answers provided, not the worked out solutions, sorry, but at least just have the answers so you can kind of check your work. And then I did do the answers. Actually, never mind. I do have the worked out solutions for my semester exam or semester review. And I did do that video last year. So I will also repost that in my community tab for those of you that are following on that. And if you care for that, it'll be on the community tab. So I hope you guys enjoy. Thank you again, guys, for joining me on the live stream. I do apologize. I know there's definitely some of you guys that got into some questions that I wasn't able to get to. But again, make sure you guys check the community tab, and I will plan on going live next week and love to answer your questions then. All right, guys, have a great night. Cheers.